So what are you guys?
We are the Swartwood family.
Hi guys, we had a request to do an AIME problem, so I believe it was something like this. It's definitely a problem you can tackle with combinatorics. So I'll look up the actual information and put it in the post, but someone sent me this and said that this is a problem from an AIME. So I think it's something like this. So basically you have these clay discs right here, like this, and they're strung up like this, and you're a marksman, and you're basically going to take out these clay discs one by one, okay? And the only rules of this, you can shoot any one you want, but you always, for any given column, have to shoot from the bottom up. So you can go boom, boom, boom like that, or you can go boom, 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 boom like that, but you can't do like this, then that, okay? So you have to shoot from the bottom up, because basically you have to hit every single one of these, okay? So the question is, how many ways can you do this? So there are a couple ways I can think of. Let's try to do mellow first. So you can think of this as the leftmost column. So you can take 3 shots in the left column, 2 shots in the middle column, and then 3 shots in the rightmost column, like this. Does everybody agree? Now, there's no restriction what sequence you do this in. You can go right, middle, left, middle, whatever. Whatever you want to do, makes no difference, right? The only restriction is that you have to hit this one before that one. But if we already know that, then we're just going to follow that. That restricts what we can do. So for example, we don't need to label these L1, L2, L3, because you can't go here, then here, then here, right? So for any left shot, the first left shot on the board, right, has got to be this one. Then the next left shot you take has to be this one. So you really don't have to encode order for the left shots because they have to go in this sequence. Same for the M's, same for the R's. So imagine thinking of that as a word. So for example, like this. Does everybody agree that encodes a specific shot sequence? It would be left, left, left. You have to go from the bottom up. Middle, middle, right, right, right. And then think of anything else you want, like left, left, right. Maybe something like that. Then what would that encode? That would encode going middle, so middle, and then, sorry, I'm on crack, left. Okay, so left, middle, left. So far we're following the rules, everything's good. Middle, right, right, then left, and then right. And that's totally fine. The only thing that restriction is doing is it's preventing us from putting the L's in a sequence, right? Like if you could distinguish these and shoot this one before that one, that gives you many different orders because you can go here, then here, or here, then here. In this case, we don't have a choice, right? So that's why we're not labeling the L's as being different, okay? So this is actually a multinomial guy. So if you remember from class when we did this, looking at a multinomial guy, the thinking is it's 1, 2, 3, 4, 5, 6, 7, 8. 8 different guys, think 8 factorial. 8 factorial different ways of arranging those letters, right? 8 for the leftmost, then 7 for the guy next to him, et cetera, et cetera. However, we're overcounting. Because with that, we're pretending all the letters are different. Like this L is different from that L, but they're clearly not. So you actually have 3 L's, right? Like L smiley, L frowny, and L confused. Okay? So when we count up here, we're counting them as if they're all distinct, but they're not. Does everybody agree? So it doesn't matter how many ways you move. If I pick these positions here to be where the L's are, you can move these L's around 3 factorial ways. And the way we count it up top, those should be distinct, but the truth is they're not because you can't tell one L from the other. Okay? Now if I'm doing this too quickly, check out what we did in class. I'm also pretty sure we put up a YouTube video on it, but since we have 3 guys, we can arrange them 3 factorial ways, we've overcounted 3 factorial times. Because we're counting the L's as if they're different, like L smiley, L frowny, L confused, but they're really just one type of L, right? Same thing with the M's, M smiley, M frowny, so 2 factorial, and the R's, R smiley, R frowny, R confused. 3 of them, we're pretending they're distinct, but they're not, so we fix it like this. Okay? So this would be the answer. I guess it would be satisfying to get an actual number here. So it would be 8 times 7 times 6 times 5 times 4, and then 3 factorial will cancel that 3 factorial. 2 factorial is just 2. 3 factorial is 3 times 2. So this would be 6, and this would be 2. That's 10, so I think 560. I think 560 is it, okay? All right, but let's do it another way. Another way of doing the same thing. You can see, just from our thinking over here, the first shot could be a left shot, or the second shot could be a left shot, like you could either do 1, 2, or 1, 2, doesn't matter, right? So maybe a way to think of it is, you've got 8 shots, right? Of those 8 shots, you're gonna choose 3 of them to be from here, okay? Does that make sense? So it's like, let's say you have 8 shots and you pretend shots number 1, 4, and 7. It's kind of like this, left, left. You're choosing those positions to be where you take the left, okay? Then what about here? Well, you've chosen 3 positions, so how many are left over? 8 minus 3 is 5. So you got 5 positions left, right? And of those, you're going to choose 2 of them to be middle, randomly like that. Okay, so how many spots are left over? Well, you have no choice. The 3 R's go here. But the thinking is, okay, you have now 5 minus 2, 3 spots left. Of these, we're going to choose the R's. There's only one way to do that. Okay? And what's making this so nice is the fact that you have to go through these in a certain sequence. So really the way to visualize it isn't so much that you have to visualize these individual guys. You need to visit these columns 8 times, where at most you can visit this column 3 times, twice, and 3 times. Okay? That's it. So again, 8 choose 3 ways of doing this, 5 choose 2 for this, 3 choose 3 for this. You have to do all these different actions before you get a result. So we multiply. So it's going to be 8 choose 3, 5 choose 2, 3 choose 3. Okay? And that's very easy to verify. 3 choose 3 is 1. 8 choose 3 is going to be 8 times 7 times 6. And then, well, let's just write it out. 8 choose 3 is 8 factorial, 3 factorial, 5 factorial. So the 5 factorial on down is going to cancel 5 on down. You're going to have 3 factorial left, which is this. You can verify it for yourselves if you don't believe me. And then we're going to do 5 choose 2. That's going to be 5 times 4. 5 choose 2 is 5 factorial over 2 factorial, 3 factorial. The 3's will cancel out. You'd have 2 here. Okay, this is 10. This is 56. 560. Okay. Now I did that really quickly because the point of this video is not to do the grunt work math-wise here. It's to show you 2 different approaches and to verify that they get you the same answer. A nice general artifact from this is the fact that you can think of multinomial as this, right? Where you're laying out positions and choosing for each of the different guys. You can actually compute multinomial this way or this way. Now I know if you just wrote out the equations, they would definitely be the same, but just the way you view them, right? One where you visualize spots, choosing them like this. Another where you're thinking about, okay, count all the possibilities, get rid of the overcounts, right? But ultimately, even graphically with the picture, you're kind of doing the same thing because you're lining up these letters and you're basically making words from the letters, right?